Welcome to qnawire.
Alright, so for part A, given that in 1983, 87% of 19-year-olds had driver's licenses and the sample size is 1,200, we can calculate the sample proportion as the number with licenses, which would be 0.87 times 1,200 out of 1,200, which is going to be 0.87. I don't know why I did that. For a 95% confidence interval, we're going to use the formula, the sample proportion plus or minus the critical z times the square root of p hat times 1 minus p hat over n. So that's going to be 0.87 plus or minus the critical z at 95% is 1.96. And so the margin of error is this right here. And so let me get those correctly in their parts. The margin of error to 4 places is going to be the 1.96 times the square root of 0.87 times 1 minus 0.87 over 1,200, and that's going to be 0.0190. And so the interval estimate to 4 places would be the 0.87 minus, which is going to be 0.8510 to the upper bound from adding 0.8890. In part B, now that p hat is 75%, also with 1,200, then the margin of error is going to be still the critical z is 1.96, but then it's 0.75 times 1 minus 0.75 over 1,200. And now to 4 places here. .0245, and so the 95% interval estimate would be from 0.75 minus, which would be 0.7255, to 0.75 plus, which is 0.7745. For the final part, the margin of error is slightly higher in the second part, part B compared to part A, which means that the confidence interval for the proportions of 19-year-old drivers in 2008 is wider compared to 1983.